So this is another typical question involving circles and simultaneous equation. So when will you know that there are simultaneous equation involved? You will know it when there is a straight line intersection with the circle. So generally, any intersection in amath or emath is the doing of simultaneous. So you can have two straight line intersecting. That is your set 2 simultaneous. You have a quadratic intersecting. So that is your non-linear simultaneous. So circle and straight line, that falls under non-linear as well. So the visualization will be something like this. So you get a circle. So there is a straight line. So you will do your simultaneous by making X or Y the subject. So from here, right, you will make Y the subject. And you do a simultaneous with the circle. That means all the Y will be changed to this fraction. So how well you get, how smoothly you manage that is your algebra skills in Sec 2. So let's say I put it in. Okay, I will not be showing everything. I will just show you something to get you started. Because this is a very technical issue. And if you are taking amath, usually this technical issue shouldn't be very serious. So it will be something like, I square the top, I square the bottom. There are two denominators, 16 and 4. So in order to facilitate, I will choose to multiply by 16. So I'll multiply by 16 on both sides. So my denominator will disappear. (16 times 5). Then from there, I carry on. So everything is left in X. So do your normal expansion, your Sec 2 expansion to your quadratic equation. So you should be able to get 2x. So one of them should be a -1. So I don't know about the other one. Okay, so according to the answer, the other one should be a 3. And you should be able to put it back here to get -2 to get a 1. So this is like the coordinates of A and B. So it'll be something like this. So in fact, right, this one will become a chord. They could have asked you to find this length because this length is just length formula if you have gotten your coordinates. So that is a simultaneous part. So it shouldn't be too much of a technical issue. Okay, then the next one, finding center and radius. So that is again a very, very basic one. From the equation, you either do your complete square or you do your formula to get the center and radius. So I'm assuming you got no issue getting this. So again, if you got issue with this, right, you got to go back to very basic circles question, just to learn how to get center and radius. The critical one is getting the equation of tangent. So the critical one is getting the equation of tangent at A. So this is the tangent. So what is the characteristic of a tangent? A tangent will be perpendicular to the radius. So a tangent will be perpendicular to the radius. So this property also happens in amath. So, and because of perpendicular, we can use m1 times m2 equal to -1. Okay, so I'm going to draw it here to facilitate. So let's take a look. So I'm just going to isolate whatever I need to. So I got the coordinate of A, and I would like this tangent. So this is the coordinate of A. So this tangent should fulfill the straight line equation, mx plus c. So if I need mx plus c, I will need the gradient. So I should have found the gradient from the radius. So that's why if I need the radius, meaning I will need the center. So this is where you get your gradient by doing a M1 and M2. Because of perpendicular, M1 times M2 will be equal to -1. So from here, I can find my M1 first by doing a length formula. So when you're doing the formula, please be careful. So this one is 3/4. So being perpendicular, so my M2 will be the gradient of the tangent. So M1 times M2 will be -1. So do it very systematically. So this topic, right, is actually very chord job. So if your foundation of chord job is okay, you will find, and you got no technical issue. Technical issue is something like simultaneous, this kind of issue. You'll find quite easy. So right now, I know the gradient already, and I got a point. So this gradient plus this coordinate should give me mx plus c. So isn't that like your normal amath chord job? If you've gotten a gradient, if you've gotten a point, then you should be able to do a mx plus c easily. So that is the idea of equation of a tangent. So nothing special, it's just that tangent is perpendicular to radius. And you already learned perpendicular concept. So it is a matter of, do you have the relevant concept? Or do you remember the relevant concept? And are you able to execute logically step by step? Otherwise, it's very much chord job. So this topic sometimes in school, the teacher will not spend a lot of time because it's under more like chord job.